In this recording, we're going to look at quadratic applications in word problems, specifically projectile motion. Now that sounds pretty complicated, but you see it all the time. Basically, you throw a ball up into the air, it makes an arc. You can see that arc when you drink water out of a water fountain. You can see the parabolic shape that the water makes. So some force makes it go up, and then gravity pushes it down. And so any projectile, a rocket shot up into the air, or a ball thrown up into the air, kicked into the air, water coming out of a hose, is going to make that parabolic shape. So I'll give you an opportunity to write down the question we have here. Matt hits a ball into the air, which is modeled by the function. So hopefully your eye is drawn to this function, and you write this function down. You're also going to want to write down what it is that h and t represent. Well, t is the time in seconds, and h represents the height of the ball measured in feet. And there's a few things we can figure out from that function. And specifically, the first thing is we're going to ask, when does the ball hit the ground? So once you've had that written down, let's consider this question together. The thing I'd like to do at the beginning is sketch out a little picture for my own sanity, just so I can start to represent this in my own head, of the flight of the ball. So this would be the h-axis, h of t, the height of the ball in feet, and this is the time axis measured in seconds. So the question is, where is the ball when it initially is hit? Well, if I am interested in when time is 0, what's the height? I simply substitute in 0 for t squared. That makes this go away. That makes this go away. Sub in 0 for t. So all that's left is 3. So what we're saying is h of 0 is 3. So I'm going to make a little plot right here. At 3, that's where Matt hits the ball. Okay, probably a baseball, right? So about waist level. And then the ball goes up. And then it gets tired, and gravity starts pushing it down, and it comes down. Okay, so that's about the path that we'll make. That parabola is a little crummy, but I think you get the idea. A little flat. So we can ask a couple questions. When does the ball hit the ground? Where does it hit the ground? How high is it? That kind of stuff. So hopefully you made your little sketch. Point to the place where the ball hits the ground. Point to that place. So hopefully you identified that right there. That's the place where the ball hits the ground. So at that point, what do we know about the ball? Well, we know that the height of that ball is 0. So when the ball hits the ground, we want to find the time. It's a when question. Find t when h equals 0. Okay? So that's that spot right there. And we don't know the height. Sorry, we don't know the time, but we know h equals 0. So in each of these questions, you're either going to be finding a time or you're going to be finding a height. And turns out we know that h is 0, so we're going to substitute 0 in for h of t. Negative 16t squared plus 102t plus 3. And now it's a matter of solving this equation. But before you do so, make an estimate. You've lived in the world for a bunch of years. You've seen balls hit up into the air. How long are they up in the air? 0.1 seconds? 50 seconds? 1,000 seconds? Make an estimate. About how long do you think the ball would be up in the air? Well, hopefully you thought, well, I don't know, maybe 5 seconds or so. It's not going to be forever. Something around that. That would seem like a reasonable answer. So let's now do the math and figure out exactly what it would be to the nearest hundredth. We have a quadratic equation, which we now know how to solve. So we're going to say what a, b, and c are. So a is negative 16, b 102, c is 3. It's already in standard form. I'm going to jump into the discriminant, b squared minus 4ac. Once you've got the discriminant, you're going to sub in the discriminant formula, 102 squared minus 4 times negative 16 times 3. At this point, you're going to evaluate that on your calculator, and you get 10,596. So let's jump into the quadratic formula. Instead of saying x equals negative b, in this case, the x is a t, right? So we're going to say t equals negative b, but that would be negative 102, plus or minus the square root of b squared minus 4ac. Hey, I just figured all that out. So I'm going to put that in the color. The 10,596 is under the square root, the b squared minus 4ac, all over 2a. Well, the a is negative 16, so that'd be a negative 32 on the bottom. Now, in almost all these cases, you're not going to have a perfect square under the radical. I think in this case it actually may be. But you can simply go to your calculator and evaluate, because we're interested in knowing the answer to the nearest hundredth of a second. So at this point, you can pop in your calculator, and you're going to get two answers. One is negative 0.03 seconds, and that would be if you did it with negative 102 plus. And the other would be, if you do it with negative 102 minus, you're going to get 6.40 seconds. Okay, so they're both places where the curve, the parabola, would hit the x-axis, but you can kind of see if I were to extend this out, I'm going to use a color here. If I were to extend this parabola down to the x-axis, it would hit right around negative 0.03 seconds. That's this answer, but of course that's not where the ball hits the ground. So I'm going to reject that solution. You just put a line through it and say reject. Can't have a negative time. This solution seems plausible, right? We said about 5 seconds the ball would be in the air, so that seems like a reasonable answer. I'm going to accept that that is probably the right answer. I could check it if I wished by subbing in 6.40 for t in both places, and it should come out really close to 0. Because I rounded, it won't be exact. All right, next question. Before I grab the next question, I'm going to grab this little picture here that I'm going to copy and put on the next screen. Next question says, when does the ball reach its maximum height, and what is its maximum height? All right, so I'm going to put that right over here, if I can grab it. Doesn't seem to want me to be able to do that. There it is. Well, that's in the neighborhood anyway. Fine. Thanks for bearing with me on that one. All right, when does the ball reach its maximum height? Put a little flag on the place where that would be. Right up here, right? That's its maximum height. That spot right there, the maximum. Also, draw a dotted vertical line down the center of that parabola. Well, that point right there is where x equals negative b over 2a. It's the axis of symmetry. The highest point is always on the axis of symmetry, negative b over 2a. So this is a when question, and it has to do with the maximum height. So I don't know the maximum height, and I don't know the time, so I can't jump into this formula to sub in a time or a height. Instead, I use the axis of symmetry. I'm going to make that note over here. Axis of symmetry. So I go t equals negative b over 2a. So that would be a negative 102 over a negative 32. That's 2 times negative 16. And I evaluate that, and it comes out, well, it's not exact, so I'm going to use these curvy kind of equal signs. That came out crummy. It comes out to be 3.19 seconds. I should have had you estimate before you did this question about how long you thought it would take to get to its highest point, given that it took about 6.4 seconds to get to there. It's not going to be exactly half. Notice how it's just slightly under 6.4 seconds. That's because the ball started at 3. So it didn't start when it hit the ground. Let me say that more clearly. It did not start at the ground. It started at a height of 3. Therefore, the highest point is not exactly half of the time when it hits the ground. But it's really close, so that serves as a reasonable estimate. The second part is, what is its maximum height? So again, when we're asked for a height and we know a time, we can substitute that time in to our formula. So it's part 2 here. This is part 1. H of 3.19 seconds. I won't put the seconds part. 3.19. And then just substitute it in. So it's negative 16 times 3.19 squared plus 102 times 3.19 plus 3. And just do that math. Just work that out. And that works out to be about 165.56 feet. You have to ask yourself, is that a reasonable height for a person to be hitting a ball? And I guess that would be quite a hit, be a high hit, but it's reasonable. Okay. Finally, the last question that we're going to pose is this one. When does the ball reach a height of 50 feet? So, get my picture in here one more time if I can. So there's my picture. When does the ball reach a height of 50 feet? Well, let me edit my picture a little bit. I think if that's 165 at the top, maybe 50 would be like right around here, not to scale. So I'm just going to draw a dotted line across. It looks like it's going to hit 50 in 2 places, once on the way up, once on the way down. So 50, after you ask yourself, is that a time or is that a height? It's a height. So substitute in place of h of t 50. And the unknown is a time because it's a when question. So this is just a matter of working out with the quadratic formula, which I would like you to do, and then play the recording when you've got an answer. All right, hopefully you had a chance to pause and work this out. We have to first get this quadratic in standard form by subtracting 50 and getting 0 on one side. We have to solve or evaluate the discriminant. I should say evaluate, not solve. Evaluate the discriminant, and I came up with 7,396. Once we've done that, the quadratic formula is half done, right? You just substitute in negative b plus or minus square root of the discriminant all over negative 32. Pop that into your calculator with a plus, pop it in your calculator with a minus. You're going to get 2 solutions, both of which are valid, right? We're not rejecting either one of them here because these are the 2 places. Right here is one of them, and right here is the other where the graph has a y value of 50 feet. And so they're both reasonable answers. They're both about what we thought they'd be. So let's recap for a moment here. I'd like you to write some notes here on your paper. What are the types of questions you could be asked about a quadratic function? And what are the tools to answer each type of question? So just reflect for a moment. What are the types of things that we asked you to do? Just pose some questions. Just jot down some questions and play the recording when you've got it. Okay, so hopefully one question you posed was, well, you could say, when does the ball hit the ground? Okay? And if I had a particular quadratic like this, I want to make a picture like this, point to where it is, and say that's where y equals 0. So you'd set the height equal to 0 and solve for x, or t, using the quadratic formula. Another way to ask this question would be, how long is the ball in the air? Again, it's a time question. How long and when are mostly asking for times. I also put a bubble over here. Estimate your answers before doing the work. That'll catch silly mistakes. Second type of question that's often being asked is, when does the ball reach a maximum height? Well, we know with this type of situation, it's a time that we're looking for, and that time can be found by the axis of symmetry. So at the maximum height, the x equals negative b over 2a. Now you know the time, so you can substitute that time into the function for x and find the height at that point. Finally, the last type of question we might be asked is, how long is the ball above a certain height? Example, 50 feet or something like that. So you would just sub in 50 for the y because you know the y. What you don't know is the time. And then subtract those two times. Thanks for watching.